Software developers are seeing six-figure salaries soar as AI-driven tools take over once routine coding, with some industry leaders calling this the dawn of a new software elite. But for every engineer leveraging AI to unlock unprecedented productivity, another faces frozen hiring or vanishing entry-level roles. Is this the moment software engineers become obsolete, or the start of a fiercely competitive race for AI-augmented dominance? The next few years will decide who gets replaced and who redefines the profession. According to projections from the U.S. Bureau of Labor Statistics, as summarized by Morgan Stanley Research, the software developer workforce in the United States is expected to grow by 1.6% each year through 2033. That adds up to roughly 17% more developers over the next decade, a steady increase, not a decline, even as AI tools become standard in the industry. This baseline stands in sharp contrast to the narrative of looming collapse. Instead, labor market data points to a moderate but persistent expansion in software roles, with no sign of mass obsolescence for those who adapt. Adoption of AI-powered coding tools is now widespread. Surveys from consulting firms like Accenture report that 2/3 of professional developers use AI assistants multiple times per week. These tools are not limited to experimental teams or early adopters. Code generated by AI is now present in nearly every major company codebase, from startups to Fortune 500 firms. Even among those who express skepticism about limits, the majority have integrated some form of automation into their daily workflow. History offers a useful perspective. Previous waves of automation, such as high-level languages, rapid application development tools, and cloud platforms, were all met with predictions of mass job loss for programmers. In each case, the demand for software grew faster than productivity gains, creating new kinds of work and raising the bar for technical skills. The pattern repeats. As routine coding tasks are automated, engineers spend more time on higher-order challenges like architecture, integration, and security. The current data shows that software engineering is not vanishing, it is evolving. The profession is absorbing AI as a force multiplier, not a replacement. While the shape of opportunity is changing, the underlying demand remains strong. For those willing to learn new tools and adapt their approach, the future still promises growth and relevance. Speculation about AI-driven job loss now dominates headlines and boardroom conversations alike. Some commentators warn that by the 2040s, artificial intelligence could automate nearly all routine programming, leaving only a handful of elite engineers in charge. These claims, often attributed to unnamed research groups or referenced in passing by executives, rarely stand up to scrutiny. No major institution, including Oak Ridge National Laboratory, has published a peer-reviewed forecast predicting most developers will be replaced by that date. Instead, these doomsday scenarios thrive in the absence of hard evidence, feeding on anxiety and uncertainty. The fear is not just theoretical. In 2024, Klarna, a leading payments company, announced that its internal AI assistant was performing work equivalent to 700 full-time employees. The company responded by slowing developer hiring ahead of its public offering, a move widely covered in the business press. Klarna's chief executive described AI as capable of doing all the jobs that humans do in certain software tasks. For many engineers, this was more than rhetoric, it was a warning shot. Surveys echo the mood. A substantial minority of developers, around 29%, say they expect AI to threaten their jobs. While not a majority, it is a significant share, especially among those early in their careers. The anxiety is amplified by high-profile statements from Silicon Valley leaders. Mark Zuckerberg has described Meta's vision of AI agents acting as mid-level engineers, capable of writing and reviewing code alongside humans. At Microsoft, record revenue per employee figures followed major layoffs, with AI-powered productivity cited as a key driver. The message from the top is clear. AI is not just a tool, it is a force that can reshape headcount and redefine what it means to be a software engineer. Inside companies, these headlines translate into real pressure. Boards demand efficiency. managers weigh whether to hire another junior developer or invest in more advanced AI tools. For engineers like Lena, the constant drumbeat of automation hype creates a sense of urgency and uncertainty. The extinction event theory, where only the most adaptable survive, suddenly feels less like science fiction and more like a plausible future. But how much of this anxiety is justified by what AI can actually do today? That question sets the stage for a closer look at AI's real capabilities. Remote work has redrawn the map for software engineering, but the effects of AI are anything but uniform. In India, Eastern Europe, and Latin America, rates for basic coding contracts have dropped as companies use AI to automate tasks once sent offshore. The days when a steady stream of CRUD apps and simple integrations fueled entire outsourcing industries are fading. Now, only specialized or senior offshore engineers, those who can architect, integrate, or manage AI systems, see stable or rising demand. For routine coding, AI offers a cheaper, faster alternative, pushing rates down and shrinking the available pool of work. Large technology companies, especially those with deep pockets, are taking a different approach. In the San Francisco Bay Area, London, and other tech hubs, big firms are spending heavily to attract AI talent. Budgets for AI-focused teams have ballooned, with top engineers commanding compensation packages in the $300,000 to $500,000 range, and sometimes far higher. These organizations view AI skills not as a cost-saving measure, but as a strategic investment, essential for building the platforms and infrastructure that power the next wave of products. Startups, meanwhile, are making hard choices. With limited resources, many opt to deploy AI tools instead of hiring more developers. Rather than building out large teams, founders lean on a handful of senior engineers who can direct AI assistants to handle routine work. This approach allows startups to move quickly and keep headcount low, but it also means fewer opportunities for entry-level developers to gain experience. The result is a widening gap. Established companies pay a premium for AI expertise, while smaller firms and offshore teams automate or eliminate the most commoditized roles. Across the globe, the impact of AI on software engineering depends on geography and company size. Wage pressure is greatest in regions and roles where work can be automated or commoditized, while the biggest rewards flow to those who combine technical depth with the ability to harness AI as a force multiplier. The landscape is fracturing, creating new winners and losers, and making the future of software work harder to predict than ever. Developers using GitHub Copilot completed coding tasks in just 71 minutes, compared to 161 minutes for those working without it. That is a 55.8% speed boost, measured in a controlled trial involving hundreds of engineers. But the story is not just about raw speed. In day-to-day practice, most developers accept only about 30% of AI suggestions, using their judgment to filter out what does not fit. The result is a hybrid workflow. AI handles the boilerplate and repetitive code, while humans focus on the trickier pieces. At Shopify, nearly every developer now relies on Copilot. They collectively accept around 24,000 lines of AI-generated code every day. Lead time to production has dropped by more than half for teams using these tools, and merge times are 50% faster. For Arjun, a senior engineer overseeing a complex payments platform, Copilot has become an essential partner. He credits the tool with helping his team move from idea to deployment in days instead of weeks, freeing up time for deeper work on system architecture and integration. Surveys back up these field results. 73% of developers say AI assistants help them stay in a flow state, keeping their focus on the problem rather than searching for documentation or retyping common patterns. 87% report that AI reduces the mental effort of repetitive tasks, making the job feel less tedious and more creative. While not every suggestion is useful, the net effect is clear. Developers who harness AI strengths are shipping more, burning out less, and spending more time on work that actually matters. Security incidents linked to AI-generated code are surfacing with increasing frequency. In one recent study, 45% of AI-created code samples failed basic security tests, introducing vulnerabilities like SQL injection and log exposure. For Java, the failure rate climbed above 70%. Even the latest language models, praised for their fluency and speed, still produce code that fails to guard against common threats such as cross-site scripting and improper authentication. These defects are not just theoretical. They have forced teams at large companies to spend months refactoring modules after subtle bugs slipped into production. Developers are aware of the risks. Surveys show that 55% of software engineers express concern about the quality of AI-generated code, especially when it comes to security and maintainability. This anxiety has led many organizations to tighten their quality assurance gates. At Lena's company, for example, the minimum required test coverage for AI-assisted code jumped from 70% to 85%. Every pull request flagged as AI-heavy now triggers an extra round of review, focusing on edge cases and security checks. The rationale is clear. AI can generate working code, but it lacks the judgment to anticipate business context, regulatory requirements, or the unique constraints of a given system. Architectural debt is another hidden cost. When AI assistants are left unchecked, they often reproduce generic patterns that do not fit a project's needs, leading to bloated codebases and technical debt that accumulates over time. Human oversight remains essential, not just for catching bugs, but for ensuring that software remains robust, secure, and tailored to its real-world purpose. In this new era, the engineer's role is less about typing and more about safeguarding the integrity of the systems they build. Regulators are stepping in. As AI-generated code spreads across critical industries, the European Union's AI Act, agreed in 2024, requires mandatory human oversight for any AI system classified as high risk, covering everything from medical devices to financial infrastructure. For software engineers, this means that even as AI writes more code, a named human remains legally responsible for its behavior and safety. Compliance teams are expanding, and engineers are now expected to document, review, and sometimes even override AI-generated outputs before deployment. In the United States, the legal landscape is murkier. The United States Copyright Office has clarified that code produced solely by AI cannot be copyrighted, raising questions about ownership and liability when AI-generated snippets end up in commercial products. Ongoing class action lawsuits challenge whether tools like GitHub Copilot have infringed on open-source licenses by training on public code and producing outputs that resemble copyrighted works. Companies are responding by adding indemnity clauses to contracts with AI vendors, shifting some of the risk back onto tool providers. Across both continents, the accountability burden lands on the humans who review, merge, and ship code, not on the AI itself. As a result, new career paths are opening in compliance, ethics, and risk management. For engineers, understanding regulation and liability is no longer optional. The external pressure to keep humans in the loop is shaping how teams build, test, and approve software in the age of AI. Maya graduated with a computer science degree in 2024, armed with a portfolio of apps and a summer internship. Her job search stretched into its 9th month as the number of entry-level postings kept slipping. Vacancy analytics show entry-level roles falling from 30% to just 20% of all software job listings in the past 2 years. Meanwhile, senior positions, requiring 7 or more years of experience, have climbed from 30% to 40%. Employers now expect new hires to supervise AI outputs, not just write code from scratch. Inside companies, the impact is tangible. A Fortune 500 firm spent 3 months refactoring an authentication module after junior engineers shipped AI-generated code that bypassed key security checks. The cost was not just in engineering hours, it was in lost trust and delayed features. Across the industry, managers worry that juniors who accept more than half of AI suggestions without understanding the code risk, introducing subtle bugs and vulnerabilities. To combat this, some teams have instituted Copilot-free Fridays, forcing early career engineers to practice fundamentals without AI assistance. For Maya, each interview brings the same questions. Can she prompt an AI to generate code, then spot and fix its mistakes? Can she debug a system she did not write herself? The traditional apprenticeship, learning by doing and building from the ground up, is vanishing. Instead, the first rung on the ladder is missing, replaced by a demand for juniors who already think like senior engineers. The risk is not just fewer jobs, it is an entire generation struggling to gain the experience needed to move up. Arjun logged into his company dashboard and saw a number that would have seemed outlandish just a few years ago: $310,000. That was his new total compensation after a recent promotion to AI systems architect. In top tech markets like San Francisco, this kind of salary is becoming standard for engineers who specialize in artificial intelligence and machine learning. Recent compensation analyses from leading tech salary platforms show senior AI engineers at major firms routinely earning between $280,000 and $350,000, while their non-AI counterparts in traditional back-end or product roles often fall between $200,000 and $230,000. The difference, sometimes 30% or more, has widened sharply since the generative AI boom began in late 2022. The premium grows even steeper at the upper end. At OpenAI, total compensation for experienced engineers can range from $240,000 to well over $1 million when equity is included. Self-driving companies like Cruise have posted offers in the $500,000 to $700,000 range for staff-level AI talent. Across the broader market, AI-centric skills now command a 15 to 25% pay advantage over similar roles without an AI focus. But it is not only about paychecks. New titles are springing up across the industry, including AI-augmented software engineer, prompt engineer, AI system architect, and AI ethics specialist. For those willing to build expertise and guide these new tools, the rewards are clear. Arjun's story is no outlier. It is a glimpse of what is possible for engineers who seize the AI moment. By 2027, industry analysts expect that 8 out of every 10 software engineers will need to master some form of AI skill just to stay in the game. This is not a distant forecast, it is a near-term reality, echoed by hiring managers and company training budgets across the globe. The learning curve is real. Microsoft's internal research shows that teams adopting AI tools often take 11 weeks to regain and then surpass their previous productivity levels. Those who persist with the transition see lasting gains, as AI handles a growing share of repetitive work, projected to reach 30% of all routine engineering tasks by 2030. For engineers like Maya and Lena, the choices are stark but actionable. Upskilling is no longer optional. It is the only way to keep pace as the ground shifts beneath their feet. The blueprint is clear. Master AI-powered development tools, learn to spot and correct AI mistakes, and build expertise in designing and integrating complex systems, skills that AI cannot yet replicate. Apprenticeship programs are evolving as well, with new pathways focused on verifying and refining AI-generated code rather than writing every line from scratch. The future belongs to those who can orchestrate teams of AI agents as easily as they once wrote loops and functions. The next decade will reward adaptability, continuous learning, and the courage to step into new roles before they become standard. Today, AI is rewriting the rules of software engineering, not erasing jobs, but splitting the field between those who adapt and those left behind. As demand for AI expertise outpaces traditional coding, the real risk is complacency, not redundancy. The future won't wait. Who commands tomorrow's code will be decided by choices made now. What role will you play? Share your thoughts below.